Welcome. Today we're going to talk about inequalities. The word inequality has the prefix in, meaning not. So it literally means not equal. And inequality, here's a definition. And yes, we will be taking Cornell-style notes. And inequality is a mathematical sentence which contains any of the following symbols. This is the is less than symbol. And it bears a resemblance to a capital L that's been closed somewhat. This is less than or equal, which is similar to the bottom half of an equal sign underneath the is less than sign. Is greater than or equal, is not equal. And these are the 5 inequality symbols. They are the opposite of equal. Okay, so an equality is a sentence which contains an equal sign, sometimes called an equation, is an equality. And an inequality is a special type of equation which contains one of these 5 symbols. So we're going to practice writing sentences on the left, and you should translate them into Mathish using inequality symbols. So here's the first one. I would write this on the left-hand side of our Cornell notes, and please do highlight the keywords x is less than -5. So you try and write that, and then we'll check the answer. And remember, feel free to pause at any time by pressing the space bar. I'm going to go ahead and reveal the answer. X is less than -5. The next question. P is not more than 3. So we're going to highlight is not more than, and take a moment, try to answer on the right hand side, and then we'll check. So when I answer this, I ask myself, can it be equal to 3? Can P be equal to 3 if it's not more? Yes, 3 is not more than 3. So that means it's equal or less. P is less than or equal to 3. Next question. B is positive. So we're highlighting that it's positive. So what are we comparing to B in order for it to be positive? The answer is it's greater than 0. C is at least 4. So can it be equal to 4? Is somebody who's at least 4 years old, could they be 4 years old? Yes. Or they could be more. So it's equal or greater. And finally, Q is not equal to -11. So what can Q be equal to? Anything except -11. So there's an inequality for each of these sentences. Now we're going to ask ourselves, what else is true? If 9 is less than x, what else do you know about the relationship between 9 and x? It would also be true that x is more or greater than 9. Mathematically, we would write it like this. 9 is less than x, x is greater than 9. So if one is true, then the other. So what happens when we turn around an inequality? When you turn around an inequality, the direction of the sign turns around. So notice the less than sign. The small arrow is pointing at the 9, and the alligator wants to eat the x. And when you turn around, say x is greater than 9, the same is true. The small arrow is pointing at the 9, and the alligator wants to eat the x. That's called the sense. The direction that the inequality symbol faces is called the sense. All right, we're going to do some graphing. The majority of this lesson is actually about graphing. So if we look at x equals 3 is a very simple graph. You've been drawing graphs like this a long time. It's a dot on 3. And from here, we're going to increase the complexity a little bit. Let's start off by trying to draw the graph of x does not equal 3. So if x equals 3 is a dot, then x does not equal 3. Well, what can x equal? It could equal 4 or 5 or 6. It could also equal 2, 1, 0, right? It's going to be all the numbers on the number line except 3. So we're going to start by drawing a circle around 3 that's not filled in. And that's showing that 3 is not part of the graph. And then we can draw arrows in each direction coming out of that. That's the graph of x does not equal 3. It's the entire number line with a hole in it at 3. If you take the graph of x does not equal 3 and the graph of x equals 3, here, let me read it. If you put the graphs of x equals 3 and x does not equal 3 on the same number line, it would be all the numbers, right? It adds up to the entire number line. When you say, okay, x is not 3, x equals 3, that's the whole number line. Any number that makes an equation true is a solution of the inequality. So let's write this and then make a question on the left-hand side to which this is the answer. How about, what is a solution? So a solution is any number that makes it true. For example, 2 is a solution of y is less than 5 because 2 is less than 5. Can you think of another solution to y is less than 5? And there's any number of them. How many solutions are there? How many different solutions of y is less than 5 are possible? The answer is there's an infinite number of solutions. Any number less than 5, which includes all the negative numbers you can think of, plus 4, 3, 2, 1, and 0, and all the fractional parts thereof. So let's talk about how you graph x is less than 5. And so first of all, we want to draw a number line. We don't need to label every point. 5 is what we call the border point. It's the border between what's on our graph and what's not on our graph. The border point always gets circled, but sometimes that circle is open and sometimes that circle is closed. And there's a rule that you can use to decide, okay? When the number equals, then you have a closed circle. And when the number does not equal, then you have an open circle. Now, this includes the less than and greater than. So if it's strictly less than or strictly greater than the border point, then you're going to have an open circle. But if it has an equal sign as part of it, like less than or equal, equal, or greater than or equal, if it's equal at any time, then you draw a closed circle. Okay, so closed circles represent the number, like we drew the circle for x equals 3 as a solid circle. If it's equal, it's a solid circle. So does this one include an equal sign? It does not. So we're going to draw an open circle at the border point 5. And if we think about all the numbers that are less than 5, it's going to be 4, 3, 2, 1, 0, -1, -2. It points to the left. I want you to notice that when the equation is solved so that the variable is on the left-hand side, the symbol here, the less than symbol, points in the same direction as the arrow. So you should always check it mathematically and make sure you're correct. Like, for example, put in a 2. 2 is less than 5. 2 on the graph here is on our line, so we're doing well. But this is my shortcut. I look at the way the arrow is facing, the symbol, the less than sign, and the arrow, and they're the same. Okay, so for a border point of 3, there's really 4 possibilities. Aside from the ones that we already graphed of x equals 3 and x does not equal 3, you could have x is less than or equal to 3, x is less than 3, x is greater than 3, or x is greater or equal to 3. So let's draw x is less than 3 first. It's going to be an open circle, and it's going to point to the left because it's less, like 2, 1, 0. X is less than or equal. If it's equal, it has a closed circle, and it's also pointing to the left because it's less, 2, 1, 0, negative 1, negative 2. X is greater than 3. Should it be open or closed? Open circle at 3, facing to the right. Greater than 3 would be 4, 5, 6, 7, 8, or 9. And for greater or equal, we're going to want a closed circle once again, because it could equal 3. And when it's equal, it's closed. And this will go to the right. 4, 5, 6 are greater than 3. Okay, so these are all the possibilities. And if you can do all the possibilities for one number, then you can do any graph at all. Finally, let's look at a couple of examples where we have the graph and we want to write the inequality. So what's the border point here? It's 4. Is it equal to 4? No, because it's an open circle. Is it greater than 4 or less than 4? Well, this arrow is pointing to the left. It's the numbers less than 4. So x is less than 4 would be the inequality for this graph. Why don't you try one on your own? This will be our last example. Write an inequality for this graph. You can pause it and then check your answer. Since this one has a solid circle at -2, it's going to include an equal sign, and it's all the numbers that are bigger than -2, which includes -1, 0, 1, 2, 3. So as x is greater or equal than -2.